Guys, I'm going to do a review here really quick of somebody's code that they submitted in Discord for the it's the Arrow Factories challenge. But their question was about, am I using properties and am I using accessibility levels right? So we'll kind of talk about a bunch of those things. I think these are things that a lot of people probably ask about. So yeah, we'll just go through this a little bit and kind of talk about. Yeah, like I've already looked over this a little bit, and there's nothing in it that I would say, oh, that's totally wrong. You got to fix it. There are things that I would do different, and again, that doesn't mean that it's necessarily a problem, but I think it's worth talking through those things of how could it be different, how might it be different. One thing I'm not going to spend a lot of time on here. There's a lot of stuff in here about like getting specific data, like this, the user input, like turning user input into a new arrow object. I'm gonna skip that. I think there's some interesting stuff in here, but I don't think that's really the meat of this. I think the user input, honestly, in some ways, like I've seen a lot of people's solutions to like Simula soup, like that tuple one where it's like the actual like tuple code is like 3 lines of code and all the user input stuff to convert text to enumerations and the other way around. They can be just like you can have 80 lines of code just for that and 3 lines for the meat of it. So anyway, I think this is all fine. I'm gonna mostly skip it. Um, so let me come down here and focus mostly on this arrow class. Um, the first thing here is that I this has a lot of these. So private static read only double. These are a bunch of, well, they're constants that are just, they're meant to be here so that you've got access to this data. Um, I think if this is your plan to make these private static read only is a very good way to do it. An alternative, and I'm trying to remember where precisely in the book this is covered. Another thing you could do here, so I might be jumping ahead, but to remove that and do private const. These are constants; they're not variables. They work a little bit differently, and they also only work for things that the compiler can like figure out. But so like an int and like these numbers, like the compiler knows exactly what these are. If you have to like create a new object or something like that, if it's not something the compiler can see, then you aren't going to be able to use constant. And then you would use a static read only. And there's actually a lot of scenarios where you would want the static read only, but we could do this. The other thing I was going to say here, though, is this is used in a couple of places. It's so if I come in here, I say find all references. It'll show me down here where this is used. One place it's used is this right here. So I have these public static properties, which again, well, I'll get to that in a second. This person wanted to expose these this data as something that the outside something you could get access to outside of the class, so I think this is a good way to do it. One thing I might do differently here, since we're looking at these, is there's a lot of ways you can do a property. This is one of the things about properties were introduced in C# and C# 1.0, and it seems like every single update to the language has messed with properties in one way or another. So it's hard to like wrap your mind around like what's going to work and what's not, or rather like what's the best way to do it. So I think this is fine. It's a get only property, and it just returns that static field that was just right here. There's nothing wrong with that. I think it's a good way to do it. However, you could shorten this, and I would probably do that myself, just because it's shorter. If you only have a getter and no setter, then you can use an expression body for the whole property. Now the catch here is that this looks a whole lot like this, and that just changed it. This now made a public static field, not a property. So it's subtle. Look for the arrow. The arrow means it's got like a body. It's an implementation. So a field can't have that, but a property will. And if it doesn't have that, it'll have the curly braces to define its body. And a field can't have that either. So it's subtle, but there is a difference. Like I said, it's one of these things where it's like, how would you know? And I can do that with all of these. Okay, there, I've done it to all of those. And I think that's an improvement. Now, the other thing is, let me go back to where so this is used here, which has now been updated. And the other place it's being used is right here. What's the one thing that I would probably do a little different here is like, so this code right here, this is computing the arrowhead cost. Two things. This is computing the arrowhead cost here with like, if it's steel, do this. If it's wood, do this. If it's obsidian, do this. The otherwise. I think that, like, again, it's fine, but not too far away here. Let me see if we can find that really quickly. Let's see. So this is the arrowhead. Right down here, there's this get arrowhead price. And this does the exact same thing. So I think I would probably consolidate it. I think what I'd do is I'd come right here and I would say arrowhead cost equals get arrowhead price. Just pass that in. And then I can delete this. And then like if I decide to change it, like let's suppose I added in another, so we got steel, wood, and obsidian. Let's say I added in another thing. I'm not going to be able to think of something that another thing you can make arrowheads out of off the top of my head, but whatever it is. If you wanted to add another one, you'd have to change it here and you'd have to change it in here, which isn't ideal. I think it makes sense to just have it in one place and then we just reuse it here and then we're good. And the same thing is happening here too for the fletching. So we can just do fletching cost equals get fletching price, pass in the fletching and get rid of all that. Let's see, does this, oh, it does compute the shaft cost. So I'm actually gonna change the white space here just a tiny bit. And does this have a get shaft cost? Does it? Doesn't look like it has that. Hang on, let me check while not recording. Yeah, it doesn't. There isn't a get shaft cost, which I think is fine. So I'm just gonna change the white space there just a little bit because these are like setting up these properties, and then these are like computing the cost. So we could make a get shaft price, and maybe we should. Maybe I can do. Let's just do. I'm jumping ahead there. Let me back up. Hang on. So what I'm doing here, just for reference, because not everybody knows these shortcuts, I select the code that I want to turn into a method, and I'm hitting Control R, and then my finger's still on the Control key. But I push Control R, and I'm holding down Control, and you see this Control R is pressed, waiting for a second key of the chord. So now, before I let go of the Control key, I'm going to hit M. So that's Control R, M. And now it's this like the Control R is usually for like refactoring things, which is changing the code. And then M is method, refactor method. And of course, like you could, oops, let me undo this again. The other possibility here, if you can't memorize the keyboard shortcuts, it's in the menu here somewhere. Let's see. I feel like there were no quick actions. Let's see. Okay, got to figure it out. So first of all, let's see. If I hit Control, so I bring up the quick actions, which is Alt Enter. There is an extract method right here. It is not in this menu, which is where I spend a minute looking for it. It's not there, but it is in Edit, Refactor, Extract method. The other thing I'll say is I was talking about holding the Control key. You do not need to do that. I just tested that out too. So you can just select this and then hit Control R, and then you can let go of it if you want. You obviously don't need to. And then Control M, and it does the same thing. So now it comes in here, it gives me a name for the method. So I'm just going to mirror the other stuff. So get shaft cost. And maybe I should pass in. I didn't do that before, but it isn't strictly needed. Oh, you know what? Let's be consistent. I'll make that a double. Okay. So now there's like symmetry, and I like that. Like I said, it isn't strictly needed. The reason these other ones existed was because, from the looks of it, this person wanted to be able to have like display in the menu. Hey, here's like the if you want obsidian arrowhead, it's going to cost this much. If you want this much, it's going to cost this much. And in terms of like picking the length of the arrow, that length really didn't matter. Because you could just say it's this much. It's five gold per centimeter or whatever, 0.05 gold, whatever the number is. Anyway, so those already existed. Like I said, I like the symmetry. It's not strictly necessary, but yeah. All right. The next thing that I would say here, so this person went kind of over the, as you say, over the top. That's not quite the right word for it. It's admirable what they've done here. They've gone to the trouble to say, look, if you made a custom arrow, and it happens to align with the elite arrow, the beginner arrow, the marksman arrow, let's count it as that. They have this arrowhead type field here, which is used in a property here, which is used in like displaying the text. So like you ordered, and so like if you chose not to create a specific arrow type, but then you happen to pick the same stuff, it tells you, hey, you created a marksman arrow, and then you can then it. Hey, I guess maybe next time I'll just do it the easy way. So speaking of, they've gone to a lot of trouble and done some pretty cool things here, like this like insert article. Like they've got all this code to like, depending on what's coming next, they'll use correct grammar, which I probably wouldn't have done, but they've done some really cool things there, and they should be very proud of that. It's cool. Like I said, I would have let that out just because it's kind of a lot to do for not a ton of value, but it is valuable. Like it is like that polish can make a big difference. So I maybe wouldn't have done that, but I'm definitely not going to remove it now that it's here. Though I think I don't. The thing that was bothering me about what was there is that the spacing was. I can't remember. I think it was like that. So I feel like it needs either an empty line here to get the symmetry of each of these branches is one thing, or not. But anyway, so maybe that's just as good. The other way was, this is very dense code. I also sometimes will do that again to keep like the symmetry. If I put this on the next line and I have an else, I'll put it on the next line too. But again, totally optional. All right, I'm going to scroll up here and talk about this a little bit. So this, like you can see these little dots. This is saying, well, hey, you can make these read only. These are computed in the constructor and they're never updated after. I think the question is it supposed to be read only? And I think that's an important question to ask, like, because you don't want to, just because you so far haven't made something, just because you haven't so far written code that would change it, doesn't mean that of necessity it is by its nature read only, that it isn't supposed to change. So for example, we could put read only in here, but these are supposed to reflect these. And I think I would say, because like the arrowhead cost is determined from the arrowhead type. The fletching cost is determined by the fletching type. So I think I would probably say these should not be read-only unless these are also read-only. And these aren't read-only. However, the same little ... is here too. There's a time and a place for immutability, read-onliness, and there's a time and a place for the ability to change stuff. Both of them are fine. However, I think for me, I like this notion of, look, we're going to create an arrow, and it like if you like deconstruct it and make a totally different arrow, like it's a different arrow at that point. And so, and if you really want that, you just make a new arrow and throw out the old one. It does potentially mean throwing out objects. In the scope of this program, we're like, it's okay. Like we make an arrow, display some stuff, and then we close the program. That's it. So there's no real stakes here. But just in the long, bigger picture, I think it's reasonable to say maybe we could make these all read only, and say if you really do want to, and that would mean this is read only as well. I was gonna say I don't know where we can actually do that because there's a. We could fix that. I don't know if we're going to. I don't know if I'm going to, but so we could do now. Now it makes sense to make these read only. So like I said, these only make sense to be read only if these are also read only. All right, there we go. So the kind of another thing I want to talk about here. For better or worse, like this, there's actually still a little thing here that says, hey, maybe you should change something here. So this says private member arrow dot underscore fletching can be removed as the value assigned to it is never read. My first thought when I saw this was that's a little weird. Why wouldn't we be using that? We should be using that somewhere. The place that's getting used, like the thing about it is the only thing we ever ask for here is really the cost. That's all we seem to care about in this challenge, and I might change it for the future, but that's like ultimately what's happening here is the cost is the only thing we care about. And it could be nice to be able to ask the arrow for its other data, for its other, what is the arrowhead type? What is the fletching type? How long is it? So I think it could make sense to have those, but as this stands, those don't exist. So this is saying, well, maybe you don't, like you could just delete them. And we could. I think we're going to have to change a place where we set those. Yeah, we just have to get rid of these because this computes the cost right here in the constructor. Alternatively, I think we could make these into, we could have some mechanism for allowing the outside world to ask for these things. And if we're going to do that, then the way I would do it is I would probably make a property, private arrowhead, like this. I'm going to kind of copy some of the other code that's in here for a moment. So we'll have a public property that allows us to get but not set the arrowhead. However, if we're going to do that, then again, we could use we could just do this, collapse that down a little bit. But then the interesting thing here is we could, like at this point, there's nothing fancy about it. And we could use an auto property. And we still want it to be a get only auto property, but we could just do that like this. And then we can delete that. Now we have to come down here and update this. So we could do that. And we could do the same thing with the fletching. So we could just, in fact, we can do that with all three of these. Just make them get only properties. And then down here, we need to fix a couple of things here. That one was actually being used, so we need to, yeah, let's do this. There. So now if we do want to access these outside of the arrow class, they're ready to go. If we can just say arrow dot fletching, arrow dot arrowhead, arrow dot shaft length. I'm gonna pick these up and move these down a little bit for the next topic I want to touch on. I'm gonna stick them down here by these. So now we have these static properties that return these private. They were static read-only fields. Now they're constants. The one thing, so for me, I feel like this is both this and this is it's a lot of boilerplate. And there was a time where you would have had to have done this. In fact, there was a time where early C#1 you would have had to have written it like this. full properties, and this is a get only property, but you know, full property, you got to do this. I have a tendency to prefer the simpler things to, like, you know, rather than a full property. Whenever I can avoid it, I will. And one thing we could do here, like I said, just there's some complexity here in that I have two things that are related to the steel price. One of them is this, it's now a constant, and one of them is this public static property. And the thing that I'm itching to do here, again, for better or worse, is to just make that 10. And then do the same thing here. Wood price 3. And then obsidian price 5. And then plastic price 10. And then goose feathers price is 10. And then turkey feathers is... As I'm looking at that, I think that might be a typo. It could be wrong, but my memory of the fletching type is that they were each different. And I don't remember, I think the plastic was more expensive. I think those numbers are wrong, but that's what's there. I'm not gonna worry too much about that. And then same with this is 0.05. And then what I'm gonna do is delete these. And this has this comment: for displaying the prices in the menus, which is what they have been used for. I'm gonna keep the comment in here, but I'm gonna change the comment, and then I'm going to change all of these to use this. Where is... I was kind of expecting, oh, I guess it's this. Yeah, so these were using that, in fact. So I guess we're done as far as that goes. So like I said, I like that better. There's people who will say, oh, well, you shouldn't, like, don't have magic numbers, which a magic number is just a random number just hanging out. These, at this point, these are not magic numbers. The only time you can use this 5 is through obsidian price. And this demagics the 5. It gives it a specific name, so you don't have to guess what the 5 is for. So I would, to me, I think this is a good, I like how this is done. I think it's a reasonable way to do it. I think my code online just had in the cost property, it just had the numbers in there. And I think even in that context, it made sense. In fact, maybe we'll pull that up and look at it. So this is my code, and like I said, you come down here and you can see, like, here's how I handled that. And again, I feel like, I mean, you're gonna encounter people who say, well, that's a magic number. You should define a constant or a read only somewhere. And I don't. I think it could be taken, like, you'll see different opinions that have validity, but I think what I would say is, to me, this is very clear cut. There's only one place where this is used in this program. There's only one place where this is used. So there's not like one thing you want to avoid is like duplicate, like having the same bit of information expressed in the code multiple times in different ways. Because if you change the cost of a plastic fletching, by the way, here, these are the numbers that I had used. We were talking about that the other one had all 10s, which I think is just a very minor typo oversight. But if you change the cost of plastic fletching to, say, 8, you got a discount. You change that in one place. It's easy to do. If I were using this in a bunch of different places, then I would have to pull it out. But in this case, like, again, like, it's very clear to me, at least. That's the important part. It's very clear to me that this is the price of plastic fletching, because that's what we're doing here. This is the one place where it's used, and it makes sense to me. Again, if we had to use this price in other places, which the other code we were just looking at does do that, it makes more sense to, like, put that put that information somewhere else that's more broadly accessible than what we've got here. But the other thing I mentioned, though, is that it makes sense to me. That's always the tricky part of writing code, is that you can write code that makes sense to you. And in fact, you can write code that makes sense to you even, 3 weeks from now. You can come back and look at it and say, yeah, that makes sense to me. One of the catches with writing code is that you will almost always inevitably end up sharing that code with somebody else to get some feedback, to get some help, to work on it with somebody. And if they don't understand the code, you got a problem. It's important to write code that's understandable. So, like I said, this makes sense to me. I think it should generally make sense, but that's always something to think about, is will it make sense to other people as well? All right, enough about that. So at any rate, to me, simplifying this down to just having these static properties that just return the value, instead of having both the static properties and also the constants, the static read-only fields, I think it simplifies the code. There's fewer elements. Fewer elements is a good thing as long as they're the right elements. There's a lot more we can talk about with that. I think maybe we've covered... one of the questions here was, am I using the accessibility levels right? So I've messed with some stuff a little bit here already, but I think... So let's talk about that, though, briefly. Everything is divided into two categories. Everything is either part of that public API, the shell, that you expect the outside world to interact with, or it is part of the implementation details on the inside. You want to provide the right public API, the right outer boundary for everything else in the system to be able to interact with your object as it needs to. However, anything that it doesn't need, anything that you don't care to share, that's not meant to be something that the outside world should know about, all of that stuff should be part of the other side, the implementation details that should be private. So that's how you make the decision. Is this something that the outside world must know about in order to interact reasonably with this object? If so, I need to make it public. If not, I should make it private. And the reason why is, if it's private, it's not like it's a security mechanism. Somebody could still get access to that code. If you want that, there's other tools, obfuscation, and there's a lot of other things you can do. It sends an intentional signal that, look, this is for me. Like this arrow class needs a method that computes the cost of the arrow depending on how long it is. And you, the outside world, are not supposed to know that. You're not supposed to ask about that. It should be irrelevant to you. The nice thing about making something private is it is trivial to change it later. And that's a really big deal, because one of the big parts of making software is that it's changeable. Software is soft. That is its main thing, is that not only does it deliver the value that you were hoping to get from it, in this case being able to compute the cost of an arrow or whatever, but the main point is that it can change what it needs to do over time or in different circumstances. And as the part where this is happening in the book, it's just before the catacombs of the class, which is kind of it's the second boss battle. It's a big test to make sure you kind of have your feet under you for working with objects and some stuff like that. Then after that, there's a bunch of stuff that are interfaces, abstract classes, inheritance, polymorphism, all these concepts that make it easier to evolve code, to change code, to swap one thing out for another. But this private thing is another one of those tools that, if by saying, look, this is private, it means that nobody else in the rest of the software, I could have 10,000 lines of code or 10 million lines of code, and this code, the only places that I have to look, if I decide this should be a little different, we're going to make sure that it's always a little bit more, whatever it is. If we decide that the way that the cost based on the length of the arrow is computed needs to change like this, you can change it, and as long as this class is still happy with that, then it's safe to make that change. And so that's one of the big things that classes do in the first place, is it provide objects, really. Classes is just one strategy for defining objects. But it creates this little boundary wherein anything that's not part of that public outer shell, the public API, anything inside of that can be changed however you need to, and nobody else cares. So any complexity on the inside is totally isolated from the rest of the program, and that's important. You don't want to write software that you have to change. That anytime you want to make one change, you end up needing to like change 10 million lines of code. That's bad design. But something like this, where you can say, look, it's meant to be just for me. It's something that I need to achieve what I'm doing here. Then it should be private. But if the outside world needs it, you make it public. One thing here that's different from what I did, and I think it's related to this public versus private thing, is how much of this stuff should have been, like almost everything here. Let's see. Public, 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 public. There's this private one, which I made, a public constructor, and then I made these as well. There were private fields here, and I made a public property. And then there's this arrow type, but there was a property down here for it right here. So we have a few private fields, and then like everything else is public. So one thing about this is there's more in this code than I had in mine, but a lot of it comes down to pricing information. It's this kind of stuff, and it's these methods here: get fletching price, get arrowhead price. I think the big question here is, should pricing information be implementation details, or should it be public? And in my code, like I've already closed it, but I had a cost property that you could ask it for the cost, and all of the code for computing that cost was all just inside of that. You make an arrow and say, okay, well, how much is this going to cost me? You don't in that paradigm, you don't think too hard or have to think too hard about the cost. On the other hand, from the outside, you have no visibility into why the cost is that, which I think makes this an interesting, so in contrast, this code here specifically said, I'm going to give the outside world information about price. I want them to have that. And in this code, they actually put it to good use. Like if you come up here, like I said, you look up here and it has like this kind of thing right here. Each centimeter costs some number. It allows this kind of stuff to actually happen, which wasn't there, like in my version. I didn't have that ability. So I think it's an interesting question, and the answer will tell you whether those things should be public or private. Does it make sense for the pricing information to be something that the outside world should know about? If so, yeah, you make them like this is the right way to do it. Even having these is, I think, relatively reasonable as well. Arguably, let's see. Like this is used now in two places, and one of them is outside of it. The other place just calls these methods. So I think like you could, at this point, you could make these private if you wanted to, but I don't like if you're going to say price is something that makes sense to the outside world. I think it makes sense to have all of these. I'd like even this, like all of that ends up being public, which is a lot of public stuff. But I don't think that's unreasonable. And in fact, to that point, maybe this one should have been public too. I made this one and I just made it private. It didn't need to be public, but it kind of makes sense to, like you said, to think about this from a more philosophical perspective of what should the outside world need here. And like I said, that choice here, cost information, pricing information, like there's a whole mechanism in here for, well, the cost is going to be a certain amount per fletching type, a certain amount per arrowhead type, and a certain amount for the length. And then we just combine those together. And the strategy around computing that cost is like, in order to do that other stuff, it must be known. Like you have to know up here, that's exactly how it works. For example, if we said, well, you know what? if you do goose feathers and wood, there's some, I don't know, some like, I don't know what it is. There's some synergy there, and so they're cheaper. Like I can put goose feathers into, you know, oh, but that's a wood arrowhead, not the material. Anyway, but I'm not able to come up with an example off the top of my head. But that's the idea, is that like if you're like, well, no, there's like this, the pricing strategy is more complicated, then it gets scarier to just say, well, you're just going to share all those details elsewhere. On the other hand, I think I would say that if you're planning on complex nuance to pricing, then I would actually probably go a step farther here and make a second class that's like an arrow price strategy or something like that. Class that you say, given this arrow, what does that look like? Give me the price, and that then you actually could swap one for another pretty easily. But anyway, I'm off on a tangent there, so I'll stop. So like I said, it predicated on the notion that this information is going to be public, that we want to share price information. I think it's totally legitimate that pretty much everything in here is public. If you said, no, I actually don't want to share that information, I want that to be something that the arrow is capable of doing, but it's supposed to be its own secret. Like it just comes up with a cost. In that circumstance, all of this stuff should be private, but then you lose your ability to, at least up here, you lose your ability to like say, this type of stuff. You have to say, oh, well, here's the basic arrow, and it's got, plastic fletching and a steel arrowhead, and it's 72 centimeters long. Anything you want to change about it? And it costs this much. Do you want to change anything about it? And then you could say, oh, maybe I want to change this. And they say, okay, well, now that you chose, obsidian instead, now it's going to cost this much. Like you still could get price information, but it would be by creating the arrow and asking the arrow for what its price is now. So you could still make it work, but it does get harder. So anyway, there's so much more we could talk about here with design. Like there's a thousand thoughts running through my head. I think we'll leave the public and private thing alone. And I think, I'm trying to think of the other question was about properties, and we've talked about that a bit. I made a few more properties here. We changed some of these to use just a simple expression body for the entire property instead of just one for the get. Could do the same thing here. Oops, that's not what I want. So we could do that. The other thing anyway. So yeah, the properties I think are good. The public and private, I think, check out, assuming that you intend to share the price information, which all indications say yes. So I think we're good. The one other thing that strikes me as just a little bit weird here is we compute all these little parts to the cost. But we don't actually compute the whole cost until somebody asks for it. So it feels like we do the job like 80% of the way and then stop, which is fine. And again, like this, the way we do this and these private, I'm gonna actually move this down here just for the sake of this conversation. I like it better up there, but I want to stick it here for the sake of conversation. We populate all of these, but then we wait to add them together until later. And like I said, like private. There's a public interface here. Like this exists. The public, and the fact that it returns a double and that's called arrow cost is part of that public API. The specifics of how this happens on the inside are implementation details. One thing we could do here, so like my code, for example, I just said, well, you know what? I'm not going to compute these in the constructor. I will just compute them. I'll just do the entire cost calculation right here in this property. So I would take this code wherever it went. I collapsed the constructor. Like I'd take this code here. I might leave that. That's probably fine. But I would take this code here and move it down to the let's see, arrow cost. I just make this at this point you need to put all the curly braces back in. Oops. Anyway, yeah, so you could take the code here in the constructor, move it out of here, and put it right here. And in fact, at that point, I can actually delete all these entirely and just do these return doubles. That returns an int, that returns an int, that returns a double. It's doing an implicit conversion from int to double here to store it in here. So now I do that, and then now, oh, I don't need the underscore on those anymore. Like I could do this, and at this point we're like, yeah, okay. Anyway, so like now we got rid of several of those other fields. They're just computed on the fly. The downside, of course, is anytime somebody asks for the arrow cost, we gotta calculate the cost of the shaft, calculate the cost of the arrowhead, calculate the cost of fletching, and add them all together. But so here, like this isn't an 80% solution. This is a 0% solution. We'll do it all later. We'll do it when you ask for the cost. The alternative could be, and by the way, again, like notice the information hiding, the abstraction that's happening here. The outside world doesn't care that we did an 80% solution. We did 80% at the beginning and then 20% later. And then now we're changing it to defer it all. 100% later, 0% in the constructor, and 100% later. Nobody cares that we're doing this. It's just this class, which is an important thing, an important lesson. It's fine that we can pick and choose however we want. So this is a possibility. I mean, you could get a little fancier here and say, well, what if we just do, let's see, the shaft, arrowhead, put that in here. So now we're going to create a slightly complicated expression. Of course, at this point now, I actually can go back to an expression body if I want. Let's see. There. That's long. I mean, this is long, but it'll call this method passing in. Wait, where is something seems weird? Were those? This didn't compile the whole time. This needs to be. I feel like this is something really weird is happening here. Hang on, let me figure this out. Okay, not a big deal. I think I just need capital. Does that compile? Moment of truth. I've made a lot of changes here, but it looks like it does all compile. So yeah, so we could do this, or we could do, like I said, we could just squish this all into one giant expression. And then we don't even need the variables, but in exchange, this is a rather long expression, and different people are going to have different preferences for it. And like I said, I'm going to switch this to this, but I might choose to wrap this myself like that. Anyway, like I said, long expression, but so anyway, so this is like we're going to do 0% of the work up front, and that gets rid of, we had 3 fields for it. We're just going to do it all on demand. So anytime anybody asks for the cost, we have to recompute it. Pros and cons to that. Like there's less storage. Each arrow doesn't need those extra fields, which they otherwise do have. The downside is anytime somebody needs a cost, I'm going to have to compute it. So I will also say, let's see, there's another possibility here, and that is to do like 100% upfront and 0% later. Let's make this a get only property. We could have a private setter or something like that, but we do that, and then we'll just come up here and we will say Anyway, we compute the cost right here, and now we still have, so it's not 3 fields for the cost, there's just 1 field for the cost, and we just compute it all ahead of time. So again, different strategies. There's something like the way that the code was before, where it felt like we do 80% of the work up front and compute the fletching shaft and arrowhead costs up front, but don't like put them together until later. Just felt a little weird. But it, like I said, it is allowed. There's like the rest of the world doesn't care that that's how it worked, and it might be a reasonable compromise under the right circumstances. But there's also like other options, the 0% thing. We're just going to defer it all until later. Or there's the 100% upfront, 0% later thing. We're just going to figure out the entire cost right now. And we're going to store that. There's going to be a double here. So every arrow is going to have its cost that it's going to carry around with it. But we'll compute that right now. So, like I said, that's the nice thing about abstraction is we can make those changes and nobody cares. Like, as long as this code is happy, everything is fine. I think I've gone on long enough here. It's already been 45 minutes. So, like I said, I think this, like I said, this was all, everything that we've talked about here. These are things that I might have done differently. I think that's worth seeing. My way isn't always the best. I like it. I feel like I've gotten to the things that I would prefer sometimes by learning lessons the hard way. Sometimes it's just nice to see a difference. Like, how would somebody else have done it? Like I said, no real like deep, like painful, dark critiques of this code. I think, like I said, I think it's good. Just some things that can be done differently, or that I would have done differently. Some things to consider for the next challenge. But yeah, so we'll wrap it up here. Thanks for joining me, and I'll see you guys next time.